Okay, let's do 2.3's homework. So these were special factoring cases, you guys. Now remember, you can do all of them using the old method with the X and the box. And it's just more work that way. Let me show you how to see the pattern. Okay, so first we're gonna see the pattern. And then we're gonna use the pattern to make it easier and faster. So I see here a trinomial, okay? So in seeing the pattern, the first thing I notice is trinomial. The second thing I notice is that I have a perfect square in the first position. And then I notice that I also have a perfect square in the last position. So perfect square, first and last. Okay, then what I do is I get the square roots of these guys. So the square root of the first perfect square, x squared, is x. And the square root of that second perfect square, y squared, is y. So now the third thing this pattern needs is the middle to be 2 times the 2 square roots. So 2 times that x, that y. And the middle is 2 times x times y. So this pattern is complete. This is the perfect square trinomial pattern. So then what we do is we take these 2 square roots that we found, okay? That's a big highlighter. We take the 2 square roots that we found and we take the sign of the term in the middle. So what we get is x plus y. So x plus y, and it'll be squared. Okay? That's D right here. Bah. Correct answer is D. Okay? Now I explained that like a lot, so it took 2-3 minutes. However, you'll see on a typical problem, it's gonna be way faster, okay? Maybe we'll get to see it in number 2. Okay, so in number 2, we've got ourselves a trinomial. I wanna look at this pattern. Maybe I got this going on again. However, I first notice that 8, 40, and 50 all have a 2 in common. They have a GCF, and it's 2. So the first rule of factoring, you guys, is always take out the GCF. Now, maybe it seems like I didn't do that on the previous problem. I didn't mention it out loud, but when I saw that my x squared had like no coefficient, the coefficient is 1, I knew there was nothing I could take out. So that I kind of didn't explain. But please always look for a common factor first. That's the first rule of factoring. So first we're going to take this GCF out. Let's come up with our new thing. So the 2 comes out. That is now our child whose hand we will hold and bring with us every step of the way while we do all the real work in the middle over here. 4x squared minus 20x plus 25. Okay, if you're wondering how I got those numbers, I got them by dividing everybody by the GCF, the 2 that I pulled out. So divide by 2, divide by 2, divide by 2. Okay, now here I am. Trinomial, check. Okay, do I have a perfect square in this beginning? Yes, I do, check. Do I have a perfect square at the end? Yes, I do, check. In the middle, do I have the square root of the first guy, the square root of the second guy times 2. So 2 times each square root times each other. So 2 times 2 is 4, and 4 times 5 is 20. And that is what's going on in the middle there, which means that the pattern now tells me that I just have to take my first square root, the sign in the middle, and my second square root, and that's it. And remember, our child is this 2, which is just going to come with us every step of the way. So we're going to have 2 times 2x minus 5 squared. That's it. That's the answer. Now we got to go see all the different ways that they could have written that, okay? This first one is they only took out the GCF. Technically, that's an equivalent expression. It's not factored all the way, but it's equivalent. Next, we have 2 times 2x minus 5, 2x minus 5. That 2x minus 5, 2x minus 5 is what 2x minus 5 squared is. So that's also true. This one, 2x minus 5, 2x plus 5, that's different. Not the same, not equivalent. That one with the plus again, not equivalent. But this is our final, most simplified version answer. Perfect, done. Okay, let's keep it going. Okay, let's fill in the blanks to make each equation true. All right, let's see what we got. Over here we have a trinomial, and they want to know what it should look like factored, okay? This is it factored with the squared, like that. So, okay, in order for this trinomial to fit the pattern that it must fit to turn into a perfect square over here, it needs to have a perfect square in the first and last spot, and the middle needs to be 2 times the square roots, the product of the square roots. So let's go see what the square roots are. This guy's square root is 5b. This guy's square root is something a. I don't know what the something is yet. And then this times 2 needs to be this. Okay? So that means that I need this times this to be 15 AB, and then times 2 I would get the 30 that I need. Okay, so I need 5B times something A to be 15, and that needs to be 3. Okay, so now if this is a 3, this is that squared, so 9. And then my factor at the end, remember, is going to be this square root, the sign in the middle, that square root. So it's going to be 3a minus 5b. Okay? Okay. All right. New pattern, you guys. We haven't really looked at this pattern in this homework assignment quite yet, but we did learn it in the previous lesson. This is our binomial pattern, okay? So when I have a binomial that starts and ends with a perfect square, first and last, and then I must be subtracting in the middle. I've got our special difference of squares. Okay, and with this one, I always end up with 2 sets of parentheses with the exact same numbers in every spot, and then I end up with a plus for one of them and a minus for the other. So we're going to see that play out. Okay, so that's what the difference of squares pattern is. That means, so same number in both spots. So 2x here, 2x here. Minus 3 here, plus 3 here. Okay, so we should have 2x and 3. 2x and 3, 1 plus 1 minus. And then what that's going to get me is basically, this is the way I explained it in class. It's basically like you distribute only the first one with the first one and only the last one with the last one. Now we know when we distribute, we have to distribute the 2x into both, and we have to distribute the 3 into both. However, because we're gonna end up with a plus 6x and then later a minus 6x that cancel out, with this pattern only, it comes out to be just this times this and just this times this. So 2x times 2x, 4x squared. And 3 times 3, 9. Oh, but they don't want me to write 9. They put a little 2 exponent for me, so they want me to put a 3, which squared is 9. Okay, alrighty, let's keep our patterns going. Here's a partially filled in diagram. Which expression does this diagram represent? Okay, this is saying x plus y times x plus y. So that is x plus y squared. Okay. They want me to complete the diagram. This is an area model. So what we do is we multiply the dimensions to get the area. For example, in this rectangle, we have x times x, x squared. In this rectangle, we have x times y, xy. In this one, we have x times y, xy. And in this one, we have y times y, y squared. So that's number 6, filling all this out. And now write an identity using the expression you chose and your diagram. Okay, when they say identity, they kind of mean formula, okay? Identity is something that's always true. Essentially, the identity this is saying is that x plus y squared equals x squared plus xy plus xy plus y squared. And then xy plus xy, I will simplify. That's 2xy plus y squared. This is the identity. So it's essentially a formula that you can use rather than distributing. Okay, let's keep going. Oh, that was it. Now we're in spiral review. Okay, I love it. This is very relevant spiral review. This is spiral review from like a day or two ago. Okay, here we go. Here's the equation of a parabola. They've given me vertex form, okay? I want you guys to be able to hopefully recognize this as vertex form. How? Vertex form is when we have something squared with x and then the number at the end. This is like our translation form that shows me my left to right translation and my vertical translation. And then the vertex will be an ordered pair that comes from the opposite of this number and that number. Okay, the opposite of this, not the opposite of that. Okay, rewrite in standard form. You might remember from a previous video, we always get to standard form with these 2 steps. 1, multiply it out. And then 2, simplify. Okay, so multiply it out. That means that x minus 1 squared, I'm going to multiply it out. okay? Meaning distribute the x, distribute the -1, you get x squared minus x plus 1. Don't forget, we do have a plus 9 at the end, equals y. And now we're at the simplify step. Like terms, x squared minus 2x plus 10 equals y. That's this equation in standard form. X squared minus 2x plus 10. Okay, real quick, you guys, I can't help myself. We learned in this step an identity, we made one actually, x plus y squared, for squaring a binomial. As a challenge, I would urge you to see if you could use the identity to multiply out x minus 1 squared without doing the distributing. Just see if it works, okay? So x minus 1 squared. Lining it up with this, the x and the x match up. The plus y is now -1, and you can follow this formula if you want. Okay, last thing, determine the y-intercept. I would normally have to do some work to get the y-intercept in vertex form, but I'm lucky enough to now have this equation in standard form. And in standard form, the y-intercept is right there, remember? That is 0, 10. Because remember, every intercept, somebody is 0. If it's a y-intercept, x is 0. And you plug in 0 for x, everybody goes away other than that 10 at the end. 0, 10. All right, that's it.